Welcome to helpyourmath.com. Today's video we're going to be simplifying completely. What we have here are fractions with one monomial term in the denominator, which makes this a pretty straightforward problem. There are many ways to do these kind of problems, but the most straightforward way is to use the separation of fractions technique. And by separation of fractions, what I'm talking about is referring to old ways of doing fractions. If you're adding fractions with a common denominator, what we usually do is combine the denominators, get this together, and add the numerators together in one fraction. And what happens is, instead of doing this addition this way, what we're doing is we're reverting back to the original form of the fractions before they were summed together to create one fraction. So for each of these, this is going to be the stencil of the work of what we're doing. We're taking fractions that were once separated and now combined. We're going to separate them again so we can make our life easier and make the problem as easy to dilute as possible. So let's begin with the first problem here. We have 3a cubed, b squared, and we're putting that over ab. We're subtracting ab over ab. Now the way this works is wherever the symbol of operation on the top for subtraction or addition takes place, we're going to place that symbol before the next term. And so now all we have to do is follow the order of rules for the division of variables, in which we're subtracting the exponents from the numerator by the denominator. Now we have a 1 here, and 3 divided by 1 is just 3. A to the third power and a to the first, we're just subtracting the exponents, and we're doing the same for the b term. Now for the second case here of ab divided by ab, anytime we have a term divided by itself, it's always going to give you 1. And to do this, you could use common numbers, like 5 divided by 5, that's 1. 4 divided by 4, that's 1. 100 divided by 100, that's 1. And also x divided by x is also 1. So if I have AB divided by AB, this is also considered to be 1 because it's a principle of division, right? The identity of 1. When you divide something by itself, it always gives you the value of 1. Our last step here is to take the remainder of the subtractions that are left, right? So we have 3 times a to the third minus 1 is a to the second. B to the second minus 1 is just b. And the negative 1 comes down for the trip. That takes care of our first problem. Let's use the same technique on the second problem here, right? So again, we're going to split the fractions at every symbol. So we have, this doesn't count because it's the negative symbol for the 16a to the fifth. We're going to separate the 8a squared and the 4a from this entire conjunction of fractions. So we have negative 16a to the fifth divided by 8a's. Then we have a plus symbol that comes between the fractions with 8a squared over 8a's. And we have a negative 4a divided by 8a. Again, we're going to divide the two numbers first. Negative 16 divided by a positive 8. Negative divided by a positive is negative. 16 divided by 8 is 2. Then we have the a to the fifth, and we're subtracting the power of 1. So we have a5 minus 1. Here we have then a positive divided by positive is positive. 8 divided by 8 is 1. A to the second divided by a to the first just leaves us with 1. A2 take away 1. And finally now, we're here at negative 4. Negative 4a's divided by 8a's, in which we have a reduction that occurs. Since the a's are common, they just go away. They have the same power. It's just the same as dividing 5 by 5, or ab over ab. Those just go away while the numbers remain. And the 4 and the 8 have a common factor, right, which is 4, and it reduces to 1/2. And so what we're going to do then is reduce the remaining exponents that we have left here, the subtractions that have to occur. So we have negative 2a to the fourth plus a to the first, which I'm leaving this 1 out, and also the exponent because you don't need the exponent symbol. And finally we have 1/2. That takes care of the second problem. Let's move on to number 3 using the same technique. This time, instead of having a positive denominator, we have a negative one. So we have to keep this in mind, that each term, whether plus or minus, is going to be divided by a negative in parentheses. This way we don't lose track of what's happening with the two terms when we're dividing positive by negative or negative by positive. So the first term is 50x to the 8th. We're going to split this from the other two pieces. We're dividing that by negative 5x cubed. Then we have a plus symbol. We have 75 x to the 5th over negative 5x to the 3rd power. And finally we have plus 5x to the 3rd. Here we don't need these parentheses, I'm sorry. And we're dividing that by negative 5x to the 3rd power again. So the first case, we have 50 divided by a negative 5. That's going to be a positive divided by a negative. That gives us a negative. 50 divided by 5 is 10. And we have our exponents here, x to the power of 8 minus 3. The next one, we have positive divided by a negative, which is again a negative. 75 divided by 5, that's going to be 15. You can use your calculators to do that calculation. Then here we have x to the 5th, take away 3. Finally, we have these two terms which are identical terms. Now when doing this one, think of 2 divided by a negative 2, right? The numbers are the same, but the signs are different. So when you're dividing signs that are different, we get the opposite symbol. Always negative if the signs are different. And if we're doing the same number, it's always a 1, right? So in this case, we have the same case for the numbers, for the terms. Only one is positive, one is negative. So we know the solution is negative, and the result is going to be a 1. So this becomes a negative 1. Now let's continue by finishing the remainder of the work. We have negative 10x's to the power of 8 take away 3 is 5, minus 15x's to the power of 5 take away 3, which is 2, and minus 1. Now be very careful when you're doing these problems also, because when you get to this final term, like the first problem here, these are identical, and it's easy to see that it's a 1. But here, this is a bit harder to see, and a lot of people are used to just canceling out and saying it's 0. Remember, fractions don't cancel out when they're identical. They reduce to 1, all right? Or in this case, negative 1. Let's get to our final one here for number 4, and we have 33y's to the 4th power over a negative 11y squared. And again, I'm using parentheses for the denominator term because it's negative, all right? And plus, for the positive top symbol, 55y to the 3rd divided by, again, a negative 11y to the 2nd. And finally, the last term is also negative 11y squared. And this is also being divided by the same term, negative 11y squared. Keep that in mind. They're identical. All right, now the first case, we have positive divided by a negative gives us a negative. 33 divided by 11 is just simply 3. Y to the 4th, take away the denominator's exponent of 2. The second term, positive 55 divided by negative 11 is negative 5. A positive by negative is negative. 55 divided by 11 is 5. Y to the 3rd power, take away 2 from the denominator. The last case is actually identical. We have negative 11y squared and negative 11y squared. We know this is the same case. Instead of negative and positive, this time we have a negative and a negative, which gives us a positive 1. So we know the last term here is going to be plus 1 because they're identical terms. Now let's do the final remainder of the work, which is just subtracting the exponents here. So we have negative 3y, 4 take away 2 is just 2. Negative 5y, 3 take away 2 is just 1. We don't need to show the 1 here. Plus 1. And that covers our video for simplifying completely when dealing with monomial terms in the denominator. Thank you.